Hello, girls. I hope you're having a great day. I hope you're staying safe at home. So, here I am today to start with a new chapter that is chemical changes and reaction. This chapter is totally based only on equations. So, I hope, children, you are up to date with your formulas. So, when we talk about a chemical change, we are talking about a permanent change, okay, in which the chemical composition of a substance is changed into one or more new substances. That means in a chemical change, what happens? A completely new substance is formed. So the reaction is not reversible. That means you will not get back the old substance. Completely new substances are formed. Okay. Now a chemical change, remember, always involves a chemical reaction. Now, when we talk about different chemical compounds, sodium chloride, copper oxide, or an element like oxygen, the atoms that is present in these compounds or the elements are held in position by a chemical bond. Okay, so there is a chemical bond between sodium and chlorine. In sodium chloride, there is a chemical bond between copper and oxygen, between copper and oxygen in copper oxide, and between two oxygen atoms in oxygen. Okay. Now, for a chemical change to take place, there are certain conditions which are very, very necessary. The first condition is mixing or close contact. Supposing we take lead nitrate and potassium iodide and keep them separately, no reaction will take place. But if we bring them together, if we mix them, then a reaction will take place. Okay? And potassium nitrate and lead iodide will be formed. The color of lead iodide is yellow. Okay, whereas the color of lead nitrate is white and potassium iodide is also white. That means sometimes in the question paper you may be asked to write down an equation between two white compounds which give a yellow product. So you will be writing down this reaction. That is how equations come in chemistry. Okay. Next is the substances must be in solution form. When we talk about solution form, it may be in the molten state. Molten means melted. That means it is liquid, or it is mixed with water. Then it is known as aqueous. Aqueous means it is mixed in water. It is turned into a solution. Now, if you take sodium chloride and silver nitrate solid and bring them together, you will see that no reaction will take place. But if we mix them in water and bring them together, then you will see the formation of a solid which is known as a precipitate. In this case, you will see a white precipitate. In chemistry, it is written as PPT. PPT means precipitate. Okay, that means it is a solid. We are taking liquid, sodium chloride in water, silver nitrate in water. Both are watery. But when we mix them together, one product is a solid and it is known as a precipitate. Okay, and with the formation of sodium nitrate, which is in aqueous state. Aqueous means again it is in water. It is dissolved in water. The next condition is heat. Certain substances, if you keep just like that, no reaction will take place. But if you heat it, you will see copper carbonate is a solid. Okay, so when you heat it in chemistry, you know a small triangle sign or delta means it is heated. It will turn into copper oxide, which is a solid, and carbon dioxide, which is a gas. Okay, so you have to heat, then only the reaction will take place. The next condition is light. Okay, the reaction which takes place in the presence of sunlight is known as photochemical or photolysis. Okay, photochemical reaction, or it is also known as photolysis. You know, in photosynthesis, photosynthesis does not take place in the absence of light. It will take place only during the daytime when there is sunlight. So in photosynthesis, 6 molecules of carbon dioxide combine with 12 molecules of water, and that takes place in the presence of sunlight only during the daytime, will give you 1 molecule of glucose, 1 molecule of carbon dioxide, and 6 molecules of water. Okay. Similarly, hydrogen and chlorine in the presence of sunlight, okay, so sunlight is used here, will give you 2 molecules of hydrogen chloride. Now, if chlorine water is exposed to sunlight, bubbles of gas are seen. That is, oxygen is given out. That is chlorine plus water. Okay, we get HCl plus HClO. Okay, so this hypochlorous acid in the presence of sunlight, okay, it will turn into hydrogen chloride and oxygen. So this is the bubble that you see. Now next, solutions of silver nitrate and hydrogen peroxide in the lab are kept in brown bottles. You may get and explain why. Why are solutions of silver nitrate and hydrogen peroxide kept in brown bottles? Because they decompose in the presence of sunlight. So in the presence of sunlight, it decomposes into silver, nitrogen dioxide and oxygen. Okay, similarly, hydrogen peroxide, 2 molecules of hydrogen peroxide in the presence of sunlight decomposes into water and oxygen. Okay, the next condition is electricity. There are compounds like water and sodium chloride which will decompose in the presence of electricity. Okay, in the presence of electricity, into its constituent elements, hydrogen and oxygen, and sodium chloride, it will decompose into sodium and chlorine in the presence of electricity. The next condition is pressure. Okay, some chemical reactions, they take place only when high pressure is given to them. For example, mercury chloride and potassium iodide, okay, when you give pressure, then only it will turn into mercuric iodide and potassium chloride. Similarly, nitrogen and hydrogen, they will react above 200 atmospheres. Okay, above 200 atmospheres. Now, the standard atmosphere is 1 atmosphere. We live under a blanket of air which is known as atmosphere, that is 1 atmosphere. So we need 200 atmospheres. It should be above 200 atmospheres, and then only ammonia will be formed. Okay. Now next we come to catalyst. You know what a catalyst is, isn't it? So some chemical reactions needs a catalyst. What does a catalyst do? It increases or decreases the rate of reactions, and the catalyst will not take part in the reaction. So it will remain unchanged. Okay. Now potassium chlorate decomposes at 700 degrees Celsius Okay, and this rate is very, very slow. Okay, at even when you heat it to 700 degrees Celsius, the rate of reaction is very slow. But if you add a catalyst, manganese dioxide, bingo, what happens? The reaction takes place very quickly at a reduced temperature of just 300 degrees Celsius. Okay. Similarly, ammonia, 4 molecules of ammonia acts with 5 molecules of oxygen at 800 degrees Celsius very quickly if a catalyst platinum is added to form nitrogen monoxide and water. Okay, now there are two types of catalyst, a positive catalyst and a negative catalyst. A positive catalyst, it increases the rate of reaction. For example, in the decomposition of hydrogen peroxide, manganese dioxide acts as the positive catalyst. That means it increases the rate of reaction, that is, increases the rate of decomposition of hydrogen peroxide, which turns into water and oxygen very quickly. Okay, and of course there are enzymes in our body. For the various chemical reaction that takes place in our body, we have enzymes which are also known as biological catalyst, YST. So biological catalyst, so these biological catalysts increases the rate of chemical reactions that takes place in our body. Now during digestion, the food gets broken down into simpler substances in just 2 to 3 hours in the presence of enzymes. Okay, so these enzymes are catalysts. Otherwise, our food takes months to get digested, and it is getting digested very fast. Why? Due to the presence of enzymes. Okay, now sometimes what happens, promoters are used. Now what are promoters? What do promoters do? It improves the efficiency of the catalyst. That means it lets the catalyst work more better. Okay, for example, when nitrogen and hydrogen react to form ammonia, iron is used as the catalyst, but the rate is very low. So what is added? A promoter which is known as molybdenum is added, and then what happens? The reaction takes place very fast. So in this case, what are we using? We are using a catalyst as well as a promoter. This promoter increases the efficiency of the catalyst. Okay, now next we have a negative catalyst. A negative catalyst means which retards the rate of reaction. That means when the reaction is taking place very fast, then it brings down the rate of the reaction. For example, in the case of decomposition of hydrogen peroxide, phosphoric acid brings down the rate of reaction. So that is a negative catalyst. I think I just missed out balancing here. There'll be a 2 year in front and another 2 year. Okay, now to continue with characteristics of chemical reactions. Now chemical reactions are characterized by certain changes that can easily be seen. Okay, so some of these changes are, first is evolution of gases. Okay, now if you take a look at this reaction where zinc reacts with sulfuric acid, hydrogen gas is evolved with effervescence, and it is written as an up arrow. Okay, so the term that you have to use is effervescence. Now effervescence means like when you open a Coke bottle, have you seen the bubbles coming out quickly? So that is effervescence for you. Okay, and when dilute hydrochloric acid is added to calcium carbonate, okay, which is a solid, and hydrochloric acid is a liquid. Okay, so you will see calcium chloride is formed, which is liquid. Water is also a liquid, and another gas is given out, that is carbon dioxide, again with effervescence. Okay, because when gases comes out through the liquid, it will form tiny bubbles. Next is change of color. Certain chemical reactions show a change in color of the reactants. For example, if you take a few pieces of iron and put it in a blue colored copper sulfate solution, okay, solution is always written as AQ. AQ means aqueous, in water. Okay, you will see the formation of a green colored ferrous sulfate, okay, and a pinkish red deposit of copper is formed. Copper again is a solid. Okay. Next, when concentrated sulfuric acid is added to a pinkish red solid, that is copper, you will see the formation of a blue colored solution. Again, you know it is written as AQ, aqueous. Okay. And water and sulfur dioxide, which is a gas. Next is formation of precipitates. We already discussed yesterday when in the conditions of reaction, like certain compounds did not react when they were solid. It reacted only when they were brought in solution form, when they are dissolved in water, when they are aqueous in solution. So that time you will see the formation of precipitate. Precipitate is a solid, insoluble solid substance. Okay, so when a solution of silver nitrate is added to a solution of sodium chloride, so both are aqueous. Aqueous means in liquid form, solution form. You will see the formation of a white precipitate of silver chloride. Precipitate is written by a down arrow. And sodium nitrate, again, which is aqueous, means it is still in solution form. Okay. Similarly, when ferrous sulfate is added to sodium hydroxide, both are aqueous again in water. They are both solutions. Okay. You will see the formation of a precipitate, a dirty green precipitate of ferrous hydroxide by down arrow, and sodium sulfate again, which is aqueous. That is, it is still in solution form. Okay, and finally we come to the change of state. Change of state means solid to liquid, liquid to gas, or vice versa. That is, gas to liquid, liquid to solid. So here you can see when we see that ammonia gas reacts with hydrogen chloride gas, a solid is formed. Okay, that is ammonium chloride. Now, this sign, you know, means it is reversible. Reversible means ammonia and hydrogen chloride will give you ammonium chloride. Again, when you heat ammonium chloride, you will get ammonia and hydrogen chloride. Okay, and another equation showing you change of state is carbon, which is a solid, reacts with sulfur, which is again a solid, to give you a liquid, which is carbon disulfide. Okay, so this is all for today. Stay safe. God bless you.